Hello, 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 digital health family. This is Grace Benton from High Tea with Grace. I'm here in sunny Philadelphia at the AAIC conference learning about Alzheimer's research and research in mild cognitive impairment. I'm here with Dr. Ali Jannati, and he is an MD, a PhD, and he works at Linus Health. So tell me a little bit about yourself, Dr. Ali, and intro yourself. Tell me about the career path that brought you to Linus Health.
Hi, Grace. It's great to talk to you here at the AAIC. So I started in medical school. I was always interested in learning about how the brain works, how the functions of our brain makes us different from other animals, from primates. I was always interested in higher cognitive functions, how they get implemented in the brain, what kind of neural processes allow us to do self-reflection, planning for our life, introspection, thinking about our own identity, and all kinds of basically higher level cognitive functions. So I did some research both in basic neuroscience, in neurogenetics, neuropharmacology, animal models early on in medical school. Then I followed that with more research in cognitive and behavioral neuropsychology and neuroscience. I was also involved in some randomized clinical trials in neurology. One of them was focused on trying to improve the treatment regimen for patients with relapsing remitting multiple sclerosis. But so after I finished medical school, I wanted to do like an actual research degree in cognitive neuroscience and trying to use both behavioral psychophysics, so visual and behavioral experimentation, together with recording what's happening in the brain in terms of the electrical activity and event-related potentials that had great temporal precision, would allow you to look at the different steps in cognitive processing on a millisecond by millisecond basis. And what happens in our brain, for example, when we are trying to focus on an object or target in our visual field while trying to suppress distractors that could be more salient. So that goes to our cognitive control. Is it more a top-down process or is it more of a stimulus-driven process? So that was kind of the focus of my graduate research. So I did my master's and PhD in Canada. And then during the last year of my PhD, I wanted to see if we can non-invasively interfere with the process, with that step-by-step process of cognition that happens in the brain. And really one of the very few tools that we have is this non-invasive brain stimulation or transcranial magnetic stimulation that allows researchers and now increasingly clinicians to essentially slice at different moments in time when a cognitive process, emotional processing, thinking and behavior is happening in the brain. We can interact and interfere temporarily with different parts of the brain that are executing a very specific function at that moment over very short periods of amount of time.
How neat. Wow, that is so fascinating.
Yeah. So I chose one of the best labs in the world. It was at Beth Israel Deaconess Medical Center, the longest running non-invasive brain stimulation center, founded by Dr. Alvaro Pascual-Leone, who became my postdoctoral advisor. So I did several years of postdoctoral research fellowship in non-invasive brain stimulation, seeing if we can look at biomarkers recorded by transcranial magnetic stimulation, investigating the mechanisms of brain plasticity in various clinical populations, from patients with autism, spectrum disorders, depression, and of course Alzheimer's disease. Turns out in all of these neuropsychiatric disorders, the way that our brain responds to stimuli from the environment, including our electromagnetic stimulation, varies quite a lot from quote-unquote normal population or cognitively unimpaired or not depressed or not on the autism spectrum. And it turns out we can use those biomarkers to differentiate and monitor the response to treatment, and in some cases, in fact, have effective neuromodulation therapeutics.
Wow, that is incredible. Incredible. That I mean, I'm just like in shock right now because I have an autistic son. My grandfather had Alzheimer's. Like, I'm just thinking about how many populations this research impacts. It's very impressive. Thank you so much for the work that you're doing in this space. Incredible. So, I kind of want to learn a little bit more about what you do now at Linus Health. So, Linus Health is a digital health company in this space, and I would love to hear a little bit more about what they do and what your job is there.
Absolutely. So it's essentially in principle, it's following the same line. Here we are trying to extract biomarkers, in this case of digital type. So Linus Health is a brain health company. We have platforms that provide healthcare products. We have a research platform that enables researchers to use various digital cognitive assessments to tap into different neurocognitive functions in the brain, whether it's executive, whether it's verbal memory, and we use, of course, the Boston process approach. We have machine learning algorithms that extract features of task performance. So rather than just looking at the outcome of a neuropsych assessment, we look at the moment-to-moment process of task completion, whether it's drawing, thinking and pausing, and information processing, or is it the acoustic signal and speech, variations in amplitude and frequency of the speech signal, pauses in our behavior. Turns out all of those digital biomarkers have important implications in order to differentiate patients with Alzheimer's and other neurodegenerative diseases, including Parkinson's and others. So we are really excited about using our machine learning algorithms that can be performed behind the scenes within a few minutes, extract those features that have been validated in terms of predictive power and differentiating between clinical and healthy populations, and really enable clinicians, especially primary care providers, to have that ability for early detection. We know for all neurodegenerative diseases, especially Alzheimer's, the earlier we detect, we have a much longer window to interact and to intervene and prevent those long-term
What they say, like time is brain, right?
That's exactly right.
Yes.
And time is neuron. So any day, any week that the identification of patients and detection is delayed, there are thousands and thousands of neurons that are being lost forever. So the focus of my research here that I just presented at the AAIC is enabling primary care providers to concurrently identify two important aspects of Alzheimer's disease. So we hear a lot about blood-based biomarkers and PET scan, and can we just rely on blood biomarkers? Turns out we can't. We don't want to start just testing everyone with blood-based biomarkers and just start treatment, or at least doing patient triage just based on a blood test. We need another component, and here is where Linus comes in. We need to have both cognitive impairment, either MCI or early dementia, preferably early MCI, and we need a likely biomarker status. So our main digital cognitive assessment, which is called the DCR, digital clock and recall, it includes an immediate recall and a delayed recall, 3 words, intervened by our digital clock drawing test. And turns out with different machine learning algorithms extracted from the same 3-minute test, we can identify cognitive impairment and we can identify the likely biomarker status as if we just put this patient in a PET scanner. Almost the same level of accuracy.
That is incredible. And I think so many times people try to separate research from care. And I love that you're intermingling the two. You're saying, okay, in the primary care setting, it doesn't have to be a specialist in Alzheimer's and, mild cognitive impairment. It can be your primary care physician. That itself too is innovative.
Right.
What kind of inspired you all to really give this, to the primary care physicians? Was what they had just not sufficient?
We know that our physicians, especially our primary care providers, are extremely time constrained. They get maybe 15 minutes with a patient. So they don't, and they have a lot of systems to go through. They have a lot of considerations that they need to check. And we know that the system is not equipped to receive all the potentially eligible patients for all these approved and emerging new treatments with anti-amyloid medications that really rely on earlier stage of disease. So if you are moderate to severe dementia, you are at those stages, it's really not much that any medication can do. So we want to leverage this digital technology equipped with artificial intelligence and machine learning to help primary care providers triage the most likely suitable patients for those treatments. Patients who have mild cognitive impairment in most cases, and patients who are very likely to have that brain AD pathology already in their PET scans if we were to scan them right now, and then focus on those. They can be referred for CSF testing, they can be referred for PET scan, and soon blood-based biomarkers are going to be a great companion, or they might even replace PET scan in the near future. But we want to focus that confirmatory testing, whether it's blood-based biomarker and or followed by CSF testing or PET scan, for those patients that we know are going to be high-quality referrals. They meet or very likely to meet all the diagnostic criteria that were recently revised for Alzheimer's disease, and we detect them early. So that will equip the healthcare systems, especially primary care settings, to really target their intervention and rule out patients who might be worried. Well, they might have heard about the prevalence of Alzheimer's, all these new treatments, but they might not in fact have mild cognitive impairment. So we can equip our PCPs to rule out the patients that might be worried, but they don't actually have cognitive impairment, and focus their attention and time and resources and referrals to those patients who are likely to be suitable candidates for treatment.
It makes way more sense. That just makes way more sense. And I love that you're filling in the blank there and making that innovation possible for these folks to be able to do it that way. So Linus Health is so inspiring to me because they have 15 posters here at AAIC, which is a ginormous conference. There's traffic in all the hallways. The hallways are buzzing with discussions about the latest Alzheimer's research and mild cognitive impairment research. It's a humongous international conference, and you guys have 15 posters and multiple presentations, main stage presentations, that's not even included in that 15 numbers. So it's just really cool to be able to hear more from your team about the types of research that you're working on that's making an impact. What are you hoping that, from the points in your research that you presented, what do you hope really resonates after AAIC with people who were able to hear it and to learn from it?
I think what we want the clinicians to get out of our research is that subtle but important change in mindset. Rather than approaching it with a little bit of defeatist perspective that no, there are too many patients, we don't have enough time, but we do have the tools. We do have the tools to enable them spending just those few minutes and getting the results almost immediately, and then focusing the resources, sending them along the appropriate referral or diagnostic pathways without causing too much burden. So many of our decision points in our Linus clinical pathways don't need to be, in fact, performed by a physician. They can be done by a medical assistant. Our assessments don't need to be administered by PCPs themselves. They can be done by medical assistant, physician assistant. Many of our next step actions can be taken by a brain health navigator. But then frees up many of the workload of primary care as well as specialist physicians to really focus their time and resources and skills at the most appropriate time and for the most appropriate group of patients. And in this case, we really want to enable them to be managing this upcoming wave of potentially interested patients, potentially worried patients that they might think they might be eligible, they don't know if they have MCI, should they get this treatment or not, what are the safety implications. And we have a brain health platform that allows a physician at each step of their clinical decision-making process. What are the risk-benefit ratio and analysis that should be considered? Is this patient at a level of risk that they might benefit much more from lifestyle interventions rather than anti-amyloid medications? We know the vast majority of patients at the moment might not be eventually eligible for medications, but we have a lot of lifestyle interventions, exercise, we have the Moving Together and Brain Health Together programs from Together Senior Health that was recently acquired by Linus Health that allow the large group of patients who can still maintain and improve their brain health without getting those medications. We still want to enable those large group of patients who might be at earlier stages of mild cognitive impairment, and we can do something about them. We can help the patients improve their physical and mental health, and that's our ultimate goal.
So inspiring. Thank you so much, Dr. Ali Jannati. It's so wonderful to connect with you. I hope you have a great rest of your conference. Thank you.
Thank you so much, Grace. It's great talking to you.
And thanks to you for joining us too. Check out the High Tea with Grace podcast website for some more great guests just like the one today. Cheers.